Okay, so yeah, we're going to play a little calculus jeopardy. All right, so here's the board.
Oh, fuck, this actually looks fun.
Yeah.
It's a secret 1,000.
It's a secret.
Oh.
It's a secret for 1,000.
Did you make this?
Okay.
Hey,
yeah,
mine's no longer.
I mean, I just threw this. It's not what you think.
Yeah, it's not
Okay.
section.
All right. It's a secret.
1,000.
Okay.
Go
Go big or go
What's
home.
your
Answer? Where the is a question?
what's a secret? Can't tell you.
I don't understand.
No,
Rush.
that was
Okay, rush.
correct. Okay. So now we got this broken up into here's derivatives.
Okay.
EDX. There's notation for derivative. F prime of x,
That's also
derivative.
Don't know
Antiderivatives
what that is. So.
and integrals.
Instead of taking a derivative.
Wild card.
Yeah, wild card then, 1,000.
Wild card.
What about it's a secret?
We'll get wild cards are currently off limits. We'll get to some.
Okay,
wild
then
cards.
F prime of X.
I'll take F prime of X
Okay.
for 1,000.
Okay, F prime of
Thousand.
x. F prime of x. Now,
He's so
we're playing Jeopardy, and so here is my. Now remember, in Jeopardy, you must phrase your answer in the form of a question, right?
What is?
Okay, so here it is. So I want to know.
Come on, why you came unprepared?
Okay.
Where's our buzzers? Beep, 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 beep.
Okay, buzzed in right here.
Damn it, what the?
So
What's like last?
Yeah.
what is 10x?
What is 10x?
Is
Correct.
wrong.
That's a term.
So are we raising our hand or?
Yeah, I would just read.
Well,
okay.
okay, that was just
So that was
an example.
1,000?
I'll subtract this.
That was 1,000?
I wrote it too, but then.
Oh,
Yeah, that was 1,000. Can I see the 200?
I thought that was a 200. Sorry. Okay, so there's a derivative. Okay.
No, I said F prime of X. It has to
Oh,
be
okay. F prime of x. All right, so that one's done. Okay,
You don't know how to do this way.
Technically, the 1,000.
Yeah, I really
Can we
don't.
pick?
You're right.
No, don't mark it off because that was just an example. Because that was bold. We didn't know where our buzzers were.
Okay.
Yeah, don't do that yet. Bad idea.
Okay, so we got plenty of them. though. We'll I'll tell you what we'll do. We'll.
Take up the guys.
So we're in class. Yeah. Yes.
You can say everything's not chat.
No,
Right.
we didn't.
Why is that not?
I was trying to
You can just hear.
Yeah.
Oh, there it is.
I told him. I told him to do like Wayne or John.
Yeah.
I told him, what? You just look like Wayne.
He wanted
Just kidding.
Okay, so that one's done, right? Okay, he's done. Okay.
The same exact color.
No, I just did that with my eyedropper tool. How's that? Okay, so another
That
one.
doesn't like
Another one. Yes, sir.
Wild card too.
Wild card for
There's still off
200.
limits.
Or do you
Okay.
want to stick with the method?
Here's wild card for. This is going to be a verbal one. You got to pay attention. Wild
Okay,
card.
come on.
Wait, a verbal math question?
So our hand
Verbal
is
well,
our
could
hand
be
is our
anything. It's
buzzer?
wild card. You could be anything. Okay. I want to know for my wild card question. Remember, you have to phrase this in the form of a question, right?
Yeah, don't remind us so people get home.
Okay.
Why do you have to phrase it in the
That's how Jeopardy works.
Yeah, but I mean, why?
Oh, I don't know.
I'd like to see
Just
no.
the rules.
Ask Rebecca, I'll tell you. Okay, so here we go. So how about I want to know this. Hang on, guys. I'm bad at. I have to. That means I have to have my questions in
Is
the form
this,
of an answer.
is this going to be about math?
Only 200.
Remember.
Yeah.
Yeah, 200.
Wild card question for 200. Okay. So.
Yeah, 200 implies simpler than 1,000.
Okay, so
But it's a wild.
this is another name for for potpourri, typically used. What is it?
What it is?
Beep.
Is it like a common?
Nope, that was your time.
No.
Diarrhea?
No.
Okay.
This is.
Okay.
You said what is another name?
Bam. Yeah. Okay. So that one's off the board.
Nobody
I
gets
know
it?
what it is, but I don't want to know what another name is for it. Yeah.
Okay. Wait. Well, I didn't get to read the whole
Can
question.
you repeat the question, please?
Okay. This is another name, a synonym for potpourri. It is sometimes used to describe a question that could be from a variety of topics.
What is an inquiry?
That's not a choice.
Wild.
What's your answer?
Wild card.
Correct.
Hey! Oh!
No, that's wrong. You didn't, that's not the formal
What is a
question.
wild card?
That's not the formal question. You get that wrong.
I got it.
There you go. Yeah. What is a wild card?
Are you serious?
Yeah.
Answer.
Yeah, you get it wrong if you don't formulate the question.
That was my wild card question.
That's too bad we're not really playing Jeopardy.
Okay. So
Street
I'm going to choose the next one. I'm going to choose the next one for you. I'm going to choose antiderivative
This is haircut chat.
for
Hey,
200.
Chad, let's see your haircut.
Anti-derivatives.
Yeah. Choosing antiderivative.
Stupid.
And here we go.
Really nice,
Chicken out.
Sure.
Oh, we're going to Jeopardy.
We are.
Wait.
It's not.
Do I need to write this down? Because this is what I could do.
Okay, you better be watching for hands.
No, we're doing buzzers.
Wait, so do I get the end or what?
Beep. Beep, 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 beep.
What's the anti-derivation?
Well,
So you have
yeah.
to under-divide it?
So yeah, exactly. So I had one back here.
And it's spelled X.
Wrong.
No.
We're doing it now. It's 2x cubed.
Ah, what is
2x cubed?
Aha!
Who got that?
Bingo.
This is bullshit.
Okay. That is okay, and
I have no form of a buzzer.
that is, by the way, what an antiderivative is. It's essentially calculus jeopardy.
Working backwards.
It's working backwards. Yeah, it's asking if the answer to the derivative is 6x squared. You're answering the question, what did I take the derivative of?
Okay,
Right?
Pretty basic stuff.
It is. It is. So how about this one? What if I tell you that
The question is what
y prime equals
they asked is actually the answer to your question.
Ah.
So it's
You
not
understand?
a question.
That just clicked for me.
Okay.
cosine x?
Yeah.
Wait, did we do another one already?
Yeah. Sine x.
No, you're pulling my leg here.
Because that is what I would have to differentiate to get this answer, right?
Yes, sir.
So that is what an antiderivative truly is. It's reversing the process of differentiation. It's asking the question, what would I have to differentiate to get this answer? Okay? And in the first, now there are a bunch of rules to this, obviously, as you might expect. Thank you.
Excuse your party.
Okay, so wild card 500.
You got it. Okay, so then what is that?
Why are you pulling a wild card out of the math book?
Huh? Oh, I'm not. Okay, should we throw another wild card?
So
real quick?
currently only $200. When am I gonna get that?
Nope, 600.
Wild card for 600?
Yep.
Didn't we just do an
Yeah, we just did 2 anti-derivatives.
Yeah.
No, the second one was.
Because we know how to do
Was an integral. Yeah. Okay, you're right.
It's an integral.
I haven't said that in such a long time.
Okay, so wild card for 600. Okay, here it is. Wild card for 600. I want to know what is the largest storage capacity on any iPod? Right here.
What is 64 gigs?
No.
Oh, gosh.
What is 120?
What is?
Wait, no, it's our check. That's our
Are we going by
I think
the?
it's more than that.
Yeah, it's
Oh, we're not.
160.
160. There it is. Yeah.
Good job, Taylor.
It's not like we're actually giving out points. It's not like that.
No, we don't give them
On an iPod, there's 160 gig
No,
iPod.
it's a
Yeah.
classic.
Yeah. It's got a little hard drive in it.
It's very useless unless you have like
Yeah.
theater,
Yeah.
like a whole collection of movies.
No,
Ew.
I had over 300 movies on my laptop and it was like 80 gigs. I don't see how you would possibly need 160 gigabytes of memory.
Okay.
So
The wild card,
If you
400
have
HP.
160.
Each movie.
It's a secret. 460,000.
It's usually like 2 gigs.
What?
So that you only get-
Okay, back to derivatives. Okay, so here's the way that when we play calculus Jeopardy, in order to make this look a little less like Jeopardy, a little more like math, we ascribe certain symbols to this. So if we want to play the
Wait,
calculus
so are we
Jeopardy,
playing Jeopardy or are we doing math?
I tricked you into doing math. So F prime and back C.
You got us.
No.
Oh. Totally thought I was doing Jeopardy, but apparently I was.
Okay, so what's the answer to that one?
What
Actually, that's not. I don't want to do that one. Let me do a different one.
Yeah,
Obviously.
obviously. Oh.
So what's the answer to that?
So we're going backwards this
What is
Yeah.
secant x?
Yeah. What is secant x, right?
Wait, so who got the money?
Okay, here's how we would write this in calculus. Okay, in calculus, what we would say is the antiderivative of.
We just said what is secant.
So you're not crossing that F?
Are you just making this up? Or?
No, this is actually in the book.
Okay, this is what we would say.
Why'd you put a C?
Well, because well, you answer that
That's
for me in a
constant?
second. You're going to answer that for me in a second. Because what we've said here is so the original the function whose derivative is given is what we call the integrand. It goes inside. This is really called an integral in calculus. This whole beast right here is an integral.
Force of a different color.
Yes, green.
That's an integral. And if we want to look at the anatomy of an integral, this part right here
Dissect it.
is called the integrand. Not that that's really that important. But the integrand is going to be the answer to the derivative always. Okay? Now, the integral symbol out here is just this curvy. What it really is a lowercase Greek s for some. And we'll see why it's that way. And then what you can think of this as being, okay, what you can think of this as being, at least for now, you can think of this as being,
It's an horrible color. Looks like
that is bad, the variable of integration.
Yeah.
So in other words, this has to match up with the independent variable.
Is that brown?
Okay. Now, for now,
Ah, this.
okay, for now, we're going to be very formulaic with this. We're not going to look at why this works at all. We're going to take a big step back here in a few days, and we'll look at what's this used for and why does this work the way it does. Okay, but for now, I literally want you to it's very practical. I just want you to get used to thinking this way, and you already know how
So
to do it.
thinking backwards.
Yeah, thinking backwards. And this was like a huge calculus half-off sale here because everything that you have learned so far this year, you can take and immediately turn into a new piece of valuable information at the start of Chapter 4. In other words, everything that we've done with differentiation and taking derivatives, you can reverse all those formulas and turn those into integral formulas. Because
Good practice.
moving from the function to its derivative is called differentiation. That's what we've done. Moving from the answer back to the function that we originally differentiated is anti-differentiation, and that's essentially what we're doing for most of the rest of the year.
So can we call it integration or?
Well, there's a subtle difference in meaning between the two. For now, it doesn't matter. For now, the best thing for us probably to call it is anti-differentiation.
Okay, that's a long term. I don't really want to.
Well, you can call it integration if you want. But it's anti-differentiation is good because the word anti means against, right?
Yeah.
It's so anti tells you that we're going the opposite direction of differentiation, right?
Okay.
So okay, so here's how this thing looks, right? So then the answer is what shows up out here. This is the function that was originally differentiated. That's what we're left with when we undo the differentiation process. We would have differentiated secant x to get the integrand, right? Now, why this c? C just means constant. It could be pi, it could be a billion, it could be 7, it could be anything. It's just some
Because
random
if you
constant.
differentiate that, then you get nothing.
Okay, because if I differentiate a constant, what do I always get for an answer? 0. So how do you know there wasn't a constant there? There might have been, right? So we always have to allow for the possibility that if this is the answer to our derivative, there may have been a constant out there that we just didn't know about.
So do we basically always have to do that?
Yes. So when you are writing down an antiderivative, the answer is incorrect, and I will not give you credit for this. I'm lenient with some minor things, but this is big. If you don't include the plus c, it's wrong. It has to have a plus c because we have to account for that possibility of a constant. Okay? So that's probably a little bit troubling because I mean it seems it makes sense, but there's something about that just is in mathematics. You want to have an answer, but you got to get used to the idea now in calculus that you can't always pin everything down. Sometimes you need some extra information to be able to pin something down. Okay. Now, before we jump into solving what we call a differential equation, and we're moving into the next phase, and this is pretty cool stuff. This is where it starts to become much, much more directly applicable to the world around us than it is with just straight derivatives. Okay, now what can we do? Let's take an example. And it doesn't even matter which one we take. Yes, sir.
Should I get wild card to 400?
Not like.
Not right now. Yeah.
Can you go back to?
Yeah, sure.
What happened to
How did you
Jeff?
get secant x?
Because you just thought backwards. You asked yourself, okay, for my derivative formulas, what was the answer? The answer to what derivative was secant x plus tangent
Yeah,
x?
but that's not the.
That's not the
The
derivative?
derivative of secant x is secant v times.
Oh, I meant times, not plus.
That is a times.
Make this. I meant to make that times.
I kind of assumed that it was.
Well, it's kind of implied
Oops.
since that's the derivative.
Sorry, secant x times tangent x. Yeah,
And down there.
and down here, yeah. So that's it.
That's
There. Secant
There you
x
go.
times tangent x. Okay, thank you. Okay, so we're reversing the process. Now, for every formula that we had then, we can flip this around and turn it into an antiderivative formula. For example, if we've got the formula, let's say the derivative with respect to x of, well, let's take sine x.
What's the
Equals what?
antiderivative of that?
What's the derivative of sine x?
Cosine x.
Cosine x.
What is cosine x?
So, then we should be able to turn that around and say the integral of what? Or the antiderivative.
Integral of sine x
Sine x is
equal. No, the integral is cosine x equals sine x.
Equals sin x plus c.
Plus c.
Very good.
You gotta have
Okay,
c.
make sense?
Yes.
Okay. So for every one that we started with, we're going to get a corresponding. Let's just try just a couple more. We did a trig one.
Can we do without trig?
Yeah, let's do a non-trig one. So what if we start off with the power rule? The derivative. This is one of our formulas. The derivative with respect to x of. Let's make this. Okay, let's do x's at first. X to the n is what?
And x to the n.
and x and then
Okay. Okay. Plus c. Good. Right. Okay. So plus. No, not plus c. Okay. So now, if we turn this around, the integral or the antiderivative of what?
Yeah, plus c equals something
the
plus c.
integral of nx to the
N minus one.
minus 1
Plus c.
equals x to the n.
Plus c. Plus c.
Okay.
It's pretty easy.
Right. No big deal. Okay, but now that's a little bit. Let's look at that one there for a second. let's look at that one. That one's a little cheesy, isn't it? How often are you going to get a standard form that looks just like that?
Well, currently, one time.
Right? I'll give you an example of what I mean. Now, if I want you to, and you did it, the very first example I gave you, you played calculus jeopardy on a power rule problem. If I want to know what's the antiderivative of, say, x cubed dx, what's the answer? What do I differentiate to get that?
X just. How the hell do you do that?
What could I differentiate? Well, I'll make it easier for you. What if there was a 4 out front?
Okay, yeah. That's,
Yeah, there you go. That's.
Then it's what?
yeah. 4 plus.
Okay. Okay, well now I'm going to take it away. What if there wasn't an x to the 4th out there?
Okay, now tell us. Because we obviously don't know.
There it is.
Who said that?
Right? Didn't that work? Because now when I take the 4 down, it's going to cancel it, right?
Yeah.
Ah, okay, see what I'm saying?
Yeah. Yeah.
Okay. Right? And so this formula maybe isn't the best. Maybe we want to rewrite this a little bit. Like what if I were to say, for example, instead of calling it at n minus 1, let's make a little substitution. Let's say something like, let's let k equal n minus 1. So we can write this in terms of something that makes a little more sense for us. So now that's going to become a k, right?
Yep.
This is going to become, if k equals n plus 1, what is? Okay. Right? Makes sense? And then, I don't want to have this n here. Well, n's a constant. Now, we don't know this yet. We will very shortly. The rules of doing antiderivatives are very similar to the rules of derivatives. We were always able to pull a constant out front with derivatives, right? Okay? We can do the same thing here. I can take this n and just put it out front. Okay, but let's not call it an n. You want to write it in terms of k. So, well,
K plus 1.
k plus 1, right? If k equals n minus 1, this becomes quantity k plus 1, right? And I'd rather have that in my answer, because how often am I going to have the perfect number out front like I did before? Usually we're going to start with something like this, right? So I'm going to divide both sides by k plus 1, and then what do I get? If I do that, this one goes away, and over here I get k plus 1, right? Now this constant is totally arbitrary, right? So say originally that constant was called C1. If I have a common denominator of k plus 1, C1 divided by k plus 1, what do you know about C and k both? They're constants. So if I divide two constants, it's just some constant, right? We never knew what any of them were anyway, right? So we could instead write this whole thing as x to the k plus 1 over k plus 1. So C1 divided by k plus 1, we're just going to call C.
2.
Right?
C2.
C's, we'll leave it general. As general as we can, right? So then there's our formula, right?
We're not that.
So that's messy. Let's write that again. Let's write it in terms of n's. So the antiderivative of x to the n dx is what? It would have been easier just to, if I'd asked you this question, you could have probably just told me this.
X to n plus 1 over n plus 1.
Yeah, right? Because I know that I would have to start off with 1 power bigger than n, because I'm going to subtract when I differentiate, right? And then that's going to leave me with an n plus 1 out front that's not there, so I must have to divide by that, right? If the coefficient's going to be 1, then I would have had to have brought that n plus 1 down and subtracted 1 to make it an n. But whatever the number n plus 1 is, it's not there, so we must have to divide it away. We need it in the denominator also. So that was our new...
Can we do an example in this form?
Sure. Yeah. Yeah, let's do that. Okay, let's try an example like this. How about if we take the antiderivative of 2x. Well, I'll put the 2 in there. That's our next step.
Okay, someone can figure it out yet.
X to the 5th dx. So take a second. Don't say anything about it. Just you do it in your head if you want to, but I want you to think about what that answer is.
X to the 4th.
Baseball?
Yeah.
Okay. Where's Tanner?
Track.
Fire. Oh yeah, don't forget him. See. Where are you guys today?
In the green.
Good luck. Thank you.
X is in the 6.
That's it, right? You got it? See the roll?
6.
Plus 6, right?
Yes.
That's it.
What?
Okay,
Because we just had.
wild card.
Okay, wild card. I want to know
Can we get something like that we
what
might know?
is the name of an animal that is completely undomesticated.
I'm looking. Oh, never mind. This can't be.
What do you call that class of animals that are completely
Oh.
undomesticated, living in nature? What are they? Wild. There it is. Okay.
Okay.
Yeah.
How can you turn something so simple into such a weird?
Okay, let's try another one.
Yeah, another wild card.
Here's my wild card.
Was that your card?
Yeah. What a waste.
How are we gonna deal with that one? Yeah. Okay, there's a couple ways we can do this. Now, there's 2 ways you could go about this. How did you think about that? What did you?
It's like the last question.
Right. I purposely made it very similar to the last one. You can truly play calculus jeopardy with this, and you can ask yourself now, what would the exact answer have to be if I'm playing jeopardy with this? I know it's got to be to the 6th power, and if I want to get a coefficient of 2, what must be the denominator? It would have to be 3, because then I would bring the 6 down and have 6 over 3, right? So that's truly playing calculus jeopardy and thinking about actually inverting the process and doing does that make sense? Where the inverse process. Okay, but we don't have to do that. We could also be very formulaic about this and just use our new formula. We could also have taken this exact problem and we could have pulled the 2 out front.
That's what I needed.
Okay. We could have pulled the 2 out front, and then we know, well, I don't know how that happened.
You didn't.
And then we know that everything in the green box is the same that we had up above, right? In the green box, I just get x to the 6th over 6 plus c, right? So then I end up with 2 times x to the 6th over 6 plus c. And when I distribute the 2, what do I get?
2 over 6 is a third.
Yeah, good. X to the 6th over 3. 2 times a constant is just a constant.
Can we do some more of these?
In your head
Say it again.
I think just doing it in your head is simpler.
Yeah, I think there's a breaking point. I think when there's simple problems like this, it is. There's going to come a point where we're going to get into antiderivatives that are sufficiently complex that you are going to want to really rely on the formulas. Yeah.
Can we do a couple more?
Yeah.
Let's do one more wild card.
Wait, Mr. Roy, I have a question.
Yeah.
So the formula is you just take the front number and you pull it out front?
Yes. Do you take the form? Here, let's go back. Here's the
Yeah.
formula.
Yeah.
The formula is right.
Term.
Yeah.
Where did I write? Did I write the formula down? I think I did back here.
It's right there.
It's right there. Okay. And just so you know, these are in your book. All of them are in your book on page 243, and I'm gonna add to
I'm gonna
the.
be honest. I don't know when the last time I opened my book was.
Okay, that's fine. You don't even need to.
Okay.
I'm going to give you a sheet that match. Remember, I gave you that derivative thing, and it's on the Moodle site.
Yeah.
I've already got it made. I'll put
Okay.
one on there that's got the interviews also.
Okay.
Can we know the secret?
Okay. What's that? Secret one?
Those ones
It's a secret.
Okay. What's your answer?
I don't understand.
Rush.
That's a question.
Yeah,
The
rush.
entire row is all rush.
Yeah.
All of them, rush.
There's a new Rush single coming out tomorrow. I mean, that's, what else aren't you guys all?
What's it
probably all
called?
you can
Staying
think
up all
about, too.
night or something?
No,
What's it
probably.
called? The
Midnight premiere.
It's called Headlong Flight.
When is it gonna be? Or where is it?
Well, it's just the radio and it's out tomorrow. I mean, not that I'm keeping track of that stuff. Okay, so let's try another one. How about this?
Where am I gonna be able to debut this?
Well, maybe tomorrow. I might be set up.
Okay. Yeah, show it to us tomorrow.
Okay, so how about this one?
Before we go to lunch.
They're just pure awesome.
Which is so good.
Rush is so horrible.
I'm being serious. They're amazing.
Okay, what about that? What about that one? What would we do if we had the antiderivative of a sum of terms like this? Now, draw on your intuition here. I purposely, I don't want to tell you the answer to this. What do you think is going to happen? Being as this is the opposite process of differentiating, right? And think when we differentiated, if we differentiated a string of terms, we always just differentiated term by term, right? Remember that? We could break it into a sum or difference of small, easy derivatives. So what do you suppose we can do with this?
Is it x
Break it
over
up.
q plus
Sure.
sin x?
Just break it up. I can, and whether I do this explicitly is up to you. You can just do this part internally, but technically, at least in your mind, what you're doing is you're breaking this up into that integral or antiderivative plus that one. But you probably could just, just do it all at once. So what's the first part?
X to the third over 3.
Okay. So the first one, this is going to give us an answer
Plus
of x cubed over 3 plus some constant called c1.
Wouldn't it be sin x though?
Why can't we just put sin x and then?
Ah, okay. Now, is it?
Multiple constants? So
What's
you
it?
You can't just tack one at the very end.
Well, right. That's you're always just going to glom them together into one at the end. Right. If I do it separately, technically I've got this answer.
So each little
Plus.
term you have to add an extra constant.
Well, but then they're just constants, and so why not just group them all into one big constant that we'll call c?
Okay.
Oh, so we really don't care what they are.
No, we don't know what they are.
Yeah.
So why do
Sure, I
you
thought
write
we were
this?
going.
You don't.
Okay. Yeah.
You don't. This is well because I'm showing you. This is internally. This is kind of the justification for making this easy. We know that the first answer is going to be x cubed over 3. Now, what do we get from this one?
So sin x
Sin x
plus constant.
plus some constant, but we don't care because we're just going to lump those into one big constant at the end anyway.
Okay.
Right? So forget, you'll never do it this way. This is how you'll do it.
Are we gonna ever actually know what the constant is?
Good question. Very good question.
Good job, Nolan.
Very good question.
Yes or no question.
Okay, so let's take an example here.
Answer your question.
Are
I think so.
Okay?
we gonna have to do this? Well, let's take an example.
I'll show you.
We were playing Jeopardy. We were doing spooky.
Okay, what about that one? This is what's called, now, this is, you can
2x.
proudly proclaim to anybody that asks you that you are now doing differential equations in your calculus class, because that's,
It's 2x.
that's what, any equation that involves a derivative is called a differential equation, and the solutions of a differential equation are what you get from calculus Jeopardy. What you could differentiate and get that result. What would y have to be so that
2x.
y prime equals 2?
2x.
Okay? So you guys know how to play this, right? We're just gonna, you've already played calculus Jeopardy. We know that
I thought we were still playing it.
we would be differentiating 2x plus c.
That C is gonna really screw me over.
Okay, so that is what we call the general solution of the differential equation.
Is this assignment already up there?
No, but I will put it up
Immediately?
very quickly.
now.
Immediately.
This is the general solution because it's got a constant in it. It's very general because we don't know what the value of the constant is. But now let's say that we know that not only that this is the differential equation, but we know that it passes through the point.
Oh, God.
It passes through the point 1, 2.
Okay, so do we plug those into that equation and solve for C and then
Uh-huh.
plug it in?
Very good. Oh my
Okay,
goodness.
we don't need to go over that one.
That's just like, someone set a snare for me up here? Look at this thing.
You need to get back to Jeopardy.
Even
That is a hazard.
Take the hint, you need to go back to Jeopardy.
Yeah, okay.
So
So if I know that,
Revenue.
so if I'm told
The math gods are
that,
giving you signs.
if I'm told that the solution has to pass through that specific point or that particular point,
Plug the point in, solve for C.
then, right, we can plug in those values of x and y, and that's gonna constrain it to exactly one answer that's gonna work, right? So if I plug the 1 in for x and the 2 in
Yeah.
for y, I get 2 equals 2 times 1 plus c, so what's c?
0.
Settle.
Settle.
So c equals 0, and we get the answer, y equals 2x. Right, okay, now this is what we call,
So it does have to say like a Spanish accent.
Yeah.
No.
that's what we call a particular solution, because it is particular. We're being very particular about our answer. It has to be the exact particular one that meets that particular criterion. Okay? Yes?
Can you explain how you did the order here?
I just made it up.
Oh, you just.
It's
That was,
arbitrary.
yeah, that was,
We could just make them up, right?
no, I'll give those to you. I'll make them up for you. How's that to do?
Oh, so you will be given an order.
Yes, I'll give you an ordered pair. Right, yes.
Are all of the questions gonna be this easy?
No.
Not this easy, but like.
No, God, no.
No, okay,
No, this is the first question.
yeah, conceptually they will be. The only part that's gonna get harder with this is when we get into, now where we'll go with calculus from here on out. Let me give you a little roadmap for the rest of the year. Okay, what we want to do is, we're learning how to do antiderivatives. Antiderivatives of these kinds of single-step problems are this easy. They don't get any harder.
Single step.
Eventually, we're going to get to taking integrals of big problems that don't directly match a standard form. They don't fit one. You see what I'm
So we
saying?
gotta make it fit.
And yeah, we gotta make it fit, and those require techniques of integration, like for example, we might, here are just some of the names. We could integrate by parts, we could use a trig substitution, we could do, we could make a U substitution. That'll be that's the one that we'll focus on the most, is picking a variable substitution that's gonna make the integral look like a normal integral for us. I'm going to give you one example of that. Now, don't panic, because we're not going to cover this for just a little bit.
We only got 3 minutes left, can you give us one more wild card?
Okay, here's my wild
Obviously,
card.
no, you're a genius.
Okay, how about if we had,
I was referring to comments.
is that a good one?
Never mind.
Let's see.
Speak for yourself.
Okay, how about if we do, be a good one. What if I do?
We're making progress. No rush.
Okay. Last thing we'll do. This is one that we actually would if we used trig identities first. But now, how could we do this problem, making it look like a standard form? Well, it doesn't quite match. Now, all the standard forms are not written in terms of x's, they're written in terms of u's, just like they are for derivatives. So, for example, we've got a list of standard forms that we can get from turning around our derivatives. So, for example, we know that the integral of, or the antiderivative of sine u, or how about cosine? Do that first. Of cosine u du is what? The derivative of what is cosine u? Sine u plus c. What's u? I don't know. Could be x, could be y, could be 2x maybe.
Wait,
Right?
why?
Should be
Where
2
did
y.
cosine come from?
I just made it up. This is the list of. Oh, we'll get to that. We know another one.
After he said it could be anything.
The derivative of sine u, excuse me, the antiderivative of sine u du. What's the derivative? What's that going to be? Negative sine, negative cosine, right? Because cosine, derivative of cosine is negative sine. So therefore, I'm going to need that negative sign there, aren't I? Times my answer.
Hang on to that one.
Okay? Well, this is the one we're going to need in this case. But we don't have a u, we have a 2x. So we could do something like this. We could say, let's let u equal 2x. Okay? And if I differentiate both sides implicitly, we could talk more about it later. Okay, I'll put the assignment up, and you guys can get your feet wet. And the first part is just calculus jeopardy.
More pictures.